Yeah, hello team. Good evening. So today we are here to discuss about the short explanation about the solar panel damage detection. Okay. So let's get into the business problem. So our client is one of the leading prominent solar energy company. So they were in the they needs to enhance the monitoring and maintenance of their large PV solar system. So basically, our client has a they were in the solar energy manufacturing company, and they were having a large PV system. So that is the solar plant. Okay, so they need to monitor and maintain it. Okay, for the clean energy. Okay, their main aim is to they want the clean energy. Okay, so the current fault, the whatever the current technique they were using, they have some fault in it, and it was inefficient for them. And because of that, like fault detection, like a detection method are inefficient, so they were seeking more effective approach to ensure the optimal performance and reliability while minimizing the resource usage. So basically this was the business problem. Okay, and when it comes to objective, we have to maximize the solar PV system uptime. So we have to maximize the PV system uptime. And when it comes to the constraint, we have to minimize the maintenance cost. Okay, so first thing, objective is we have to maximize the solar PV system uptime, and we have to minimize the maintenance cost. Okay, so then like what are the business success criteria? So we have to reduce the system downtime by 15%. Okay, this was our like business success criteria. And we have the economic success criteria. So we have that achieving a 10% in a reduction of the maintenance cost associated with the solar module faults. So the economic success criteria is we have to achieve the 10%, at least 10% reduction in the maintenance cost. Okay, so this was all about the business understanding. Okay, so by going next, okay, let me enlarge the thing. Okay, so by moving further, and we have the architecture, like our project architecture. So we began with the data collection. Okay, so like we have collected the base data. So after data collection, we have uh, pushed the data into the S3 bucket. So for safe and secure, we are using the S3 bucket. So through S3 bucket, we have performed some data pre-processing. So like resizing, normalization, and image augmentation and data splitting. So after all these data pre-processing, again we push the data into S3 bucket. Okay, so through the S3 bucket, we access our data and we perform the model building. So we have used the YOLO models to perform the to build the model building. So we have the YOLO models. So by using the average precision and the mean average precision, we have we have came up with the best model by using the by considering the number of epochs and the learning rate. So by considering all these parameter, we came up with the best model. Okay, through the best model, we actually deployed in the Streamlit application for monitoring and maintenance for the end user. So after all this model deployment, like selecting the best model, so after all this we have deployed in a Streamlit, that is model deployment. And after that we have I give the UI for the our end users for monitoring and maintenance. Okay, this was the architecture where we worked on. Okay, and next we have, let me see the, so what are all the classes actually we are used in the this project. Okay, so in the solar panel, actually, we have the client has mentioned the different types of defects. Okay, they were facing the bird drops and the dusty electrical damage and the physical damage and the as well as the snow. So let's say one by one. So what are all these defects defines? Okay, So defects, okay. Okay, so defect, the general defects affecting the panel performance. Okay, so next one we have the non-defective, the area of the panel without any visible damage. Okay, and next we have the burr drops. Okay, and then we have the electrical damage, the damage due to the electrical issues such as the burn mask or the hot spot. So basically the whatever the like burns or the mask burn mask or like hot spot, they were all comes under the electrical damage. Okay, and next we have the physical damage. Okay, the physical breakage like the cracks in the panels where like are comes under the physical damage. Okay, and next last one you have the snow, the accumulation of the snow obstructing the panels. Okay, like whatever the snow falls on the panel, so like it will reduce the performance of the solar panel. Okay, so these are all the what you call the classes which we define in our projects. Okay, and the last one is that we have the dust. Okay, the dust are like dirt accumulation and the affecting the solar panel efficiency. So these are all the like the what you call the models are like classes we define in our mod in the project. Okay, and like let me see like some of the snippet of the our classes. Okay, can you see that a the picture a like defines the bird drops. Okay, this was the snippet of bird drops in the solar panel, and we have the and the dust panel. So these are all the dust like which accumulate on the solar panel. And see we have the hotspot here. So can you see the hotspot? So basically this was the electrical damage. And d, so the d, it will show the cracks on the solar panel. So basically it will define the physical damage. Okay, and next one we have the e, that is the snow falls. Okay, that snow is accumulate on the panel. And as well as the last we have the non-defective, that is a clean panel. So by considering all these six classes, we train our model so it can capable of identifying the different types of defect are based on the scenario. So not only the defects, the our model can capable of identifying the non-defective solar panel also. Okay, so we trained our model in such a way like that, so it can identify different types of defects, whether it's a dusty, physical damage, or electrical damage. Okay, whether it is a test and it's a clean. Okay, so these kind of things are included in our model building. Okay, and this is the our model building accuracy parameter. So actually we have used a lot more models. That is, we have used the VLO V5, V7, V11, and V9. So among all these, VLO V8 gets the best accuracy of 87.5%. So we have considered this was the best model. So our model achieved the MEP 50 and MEP 5095 across the 89.7% and the 74.3%. So among these, the yellow V8 model gets the best accuracy. Okay, so by considering these MEP 50 and MEP 5095, we have concluded that yellow V8 is our best model. Okay, and we have deployed our models for the client end user for usage. So this was the deployment part. So where we can see it's a clean panel. Can you see that there is no defects and nothing else is clean? So it will detect as a non-defective. Okay, there is nothing like a what you call like a cracks or a dust or a border up in it. So because of this, like it identifies it's a clean non-defective panel. In the right hand side, can you see that there is like some cracks on the panel? Okay, so because of this crack panel, the crack panel comes under the physical damage. So it will identify it as a physical damage. Okay, so this was the deployment actually we did on the using the Streamlit application. Okay, so this was all about the project explanation, that is the solar panel damage detection. Okay, so what 360 offers for you? So, okay, we have challenging real-time projects that pushes your limits. Okay, and we have learning of all phases of the project methodology, like you can like you get a chance of working on all the phases of project methodology, so including the business understanding, data understanding, and the model development and the deployment. Okay, so and data collection. So these are the project methodology, like you get the chance of learning all these. Okay, and learning about the different tools used in the industry like Python, Power BI, and as well as the cloud platforms. Okay, not only these three, like we have like many other tools. Okay, you can capable of like we can like, get a chance of working on those things. Okay, and work on research paper that are published in the international journals. Okay, and next we have the access to various free tools enhance your learning. So when it comes to free tools, we have the mind map, and we have ML architecture assistant, and we have ROM, that is the resume optimization hub. So where there we can upload your resume and upload your JD. So we can compare your resume whether like my resume like how with respect to JD how it's matching, and how it's capable of shortlist the resume. You can also like go and check out in our 360 DigiTMG website, and we have animated learning. Okay, so these are all the free resource, we can say the free resource we are offering to our students, so they can utilize and they can grow in our career like in getting a job. Okay, so and we have in the three different branches, that is in the Hyderabad, Bangalore, and Chennai. So for any more information, please contact the these numbers to like get a clarity and like what are upcoming courses we have. So inquiry on that. So we have in Hyderabad, Bangalore, and Chennai. Okay. So for more information, contact this number. Okay. Thank you. Thank you. Thank you for attending this session.